Okay, so this first triangle that we have here, triangle ABC with triangle BDE on the inside, we did ones like this already when we were setting up our proportions for our similar triangles, where we would say BD over BA, the whole side, equaled BE over BC, the whole side. Well, in those ones, we did not necessarily know that these two lines were parallel. If you know these two lines here are parallel, we actually have something called the side splitter theorem. That lets you set up a different proportion that's sometimes easier to solve than the part over the whole type that we've done before. So what this theorem says is that if you know DE is parallel to AC, then you can say that side BD divided by, so taking this side here, you can put it over just this part DA. So part over part would equal BE over EC. And so the thing that you want to keep in mind, though, is if we do not have parallel lines, or if we do not know they're parallel, we have to go back and do it the way we had done it before. And the way we had done it before was BD over the whole side BA and BE over the whole side BC. So it depends on if you see those parallel markings or not. So if you see them, you can set up your theorem this way. If you don't see them, you go back to the way we had done it. Okay, so let's look at an example of how we would use the side splitter theorem. So when we look at this picture and we want to try to set up a proportion so we can solve for x, because that's the whole point of this unit, is to set up different proportions that let us solve for x. So I know that I have this side here, x. Because these two are parallel, I can take x and put it over just 36. So because I put x on top, I would have to put this length here on top. So do I know what that length is? Okay, we would subtract 45 from 55 to get 10. So we would say 10 over, and then we'd say over this bottom length, 45. That's how we use the side splitter theorem to set it up. If we wanted to do it the old way, we would have done x over, and then we would have had to add these two together, equals 10 over 55. Now both of these will give you the same answer, but which one looks a little simpler to solve? The side splitter. So if you know these are parallel, use the side splitter. It usually makes your proportion look slightly simpler. If you do not know these are parallel, you have to do it this way. Okay? But it's not wrong. So if you forget the side splitter, you could still always do it this way. Okay, so let's go ahead and cross multiply. We get 360 equals 45x. Divide both sides by 45. And you get x equals 8. So that's how we use the side splitter theorem. Yeah.
What'd you get from 36?
So this was the other, like how we did them last week. I had to figure out what's this whole length.
Okay.
So to figure that out, we would add these together to get the whole length.
Oh, okay.
So little triangle over big triangle, little triangle over big. So you could, it would work. We would get the same answer. It just is a little more work to do.
Okay.
That's why side splitter is sometimes a lot nicer. But we have to know those lines are parallel to use it though.
Okay.
Okay, our second theorem that we're going to use to help us set up proportions deals with angle bisectors. So this one doesn't have a fancy name. It's just what happens when you have angle bisectors in your triangle. So an angle bisector is a line that ray that bisects an angle. And so what this theorem says is that if BD bisects an angle, then what'll happen is if you were to take this side AB, it will be proportional to BC. So in other words, you're taking BA over BC. That's going to equal AD over DC. So in other words, if you were to take this side A over this side B, it will equal C over D. So this one, if we have an angle bisector, it just gives us another way that we can set up a proportion to find a missing piece. And so an example of how we do or use the angle bisector theorem . I will, yes. So we would want to try to set up our proportion using our theorem. So start with the sides of your triangle, the ones that are not split. So I would take 54 over x. So this side over this side, the two sides that make up your angle. That'll have to equal, since I went with 54 first, I'm going to go with 40 on top. So 40 over 36. So if you notice, 54 and 40 came from the same triangle. X and 36 came from the same triangle. So keeping like parts together, whether it be on top of each other or both on top, both on bottom, as long as you stay consistent, it's not going to matter. Okay, so if you wanted to, you could have written it as 54 over 40, x over 36, as long as it's consistent. From here, I would reduce these numbers before we start, just so we get some smaller numbers to work with. So a number that goes into 40 and 36, 4? 10 and 9. So we have 10x equals 9 times 54, 486. Divide both sides by 10 and we get 48.6 for x. Okay, so those are our two theorems that we're going to work with today. All your problems are going to have either a side splitter or an angle bisector kind of deal going on. Okay, any questions at this point? Okay, I do want to go over one more example of each one just to make sure we got it. Okay, so I'm going to go ahead and draw out the pictures for our examples. So there's our first one. Here's our second one. And then our third one. And I'll move it up when it comes time for the third one. So looking at number 1, how might we set up that proportion so that we can solve? It's our side splitter theorem. So what would you put on top? What would you put on bottom? Okay, 6 over 21. All right, so 6 over 21 equals x minus 1 over 3 plus x. What I would do is reduce the fraction if you can, so we have some smaller numbers to work with. So if I reduce these both by 3, I'll get 2 over 7. So 7 times x minus 1 equals 2 times 3x plus 1. Distribute the 7. Distribute the 2. And then I'm going to subtract 6x to both sides and add 7 to both sides. And we get x is equal to 9. Okay, what about the second one? How might you set up the proportion for the second one? Krista?
20 over 45, 18 over x.
20 over 45 equals 18 over x. So you did this side over this side equaling the small side over the larger side. Very good. So from here, again, I'm going to simplify before I cross multiply. So what's a number that goes into both 20 and 45? 5. Okay, so that'd be 4 and 9. So let's see. 4x equals, what's 9 times 45? Or 9, what is it?
162.
162, thank you. And then when we divide, what do we get? You get 40.5? Good. Okay, how are we doing with those two? Yeah.
So, could you do it the opposite way, like 3x plus 1 over x minus 1, and then
If you flip this side, then just make sure this side's also flipped. Yeah. There are multiple ways to set up the proportions. What you're looking for is that as long as after you cross multiply that resulting equation's the same, then yes, there's different ways you can do it. Like by flipping both, you're just putting this side on top, this side on bottom. Some people will even do small over small, large over large piece, and it still comes out the same because they're all equivalent ways that you can write proportions. Okay, last one. Number 3. Do we have side splitter? No, we don't know anything's parallel. Do we have an angle bisector? Where? Where are the markings that it's an angle bisector? Nowhere. So no, we don't have an angle bisector. So what do we do if we don't have either one? We do it the basic way, the normal way, or the old way, whichever vocab you want to look at. So I notice that I have this triangle right here that I'm going to just redraw because I have some overlapping triangles here. So I have my side that's 14 and my side that's 8. So that's this one right here. Now I have a second triangle also that is also a right triangle, and that's this one here that I'm going to kind of squiggle in purple. So if I think of that one as being rotated, I can draw it in the same orientation, where my height becomes x and my base is 8. So again, taking this one here and flipping it so that 8 and 14 correspond, and that x and 8 would now correspond. How would you set up your proportion? Krista?
X over 8, 8 over 14.
X over 8 equals what?
8 over 14.
8 over 14. So cross multiply and you get 64 equals 14x. And when you divide both sides by 14 here, you do not get a nice decimal. So when you don't get a nice decimal like 0.5 or 0.2, you don't get something that terminates, just leave it as a fraction in reduced form. So 32 over 7 and leave it there. Unless the directions specifically say to round, don't do a decimal if it's not a nice one.